Okay, chemistry kids, here we go. New unit, unit 4, bonding and naming. Here are your objectives, and here where you can find them in the book. So if you need extra help, feel free to look those up. All right, so we're going to go through this in parts, and hopefully it all makes sense in the end. First one, the basics. So how can I figure out how many valence electrons I have, an element has? Well, you can do the electron configuration, is one way of doing it. Electron configuration, or you can go even tell by the group number. All right, so like elements in group 1 have 1, elements in group 2 have 2, elements in group 3 have 3, so on and so forth. So when I'm talking about these, in terms of electron, how many electrons they have, I'm not talking about the transition metals. This is D block. I'm just talking about the S and the P's. All right, so make sure you guys remember that. That should be review. All right. How is having the number of valence electrons useful? Because it can tell me the ions. All right. So it's important to figure out what type of ion it is. If it's, in other words, if it's going to lose or gain electrons. Remember, a cation is positively charged, and an ion is negatively charged. All right. So positive charge means it loses electrons. Negative charge means it gains electrons. So, which would basically answer this next question. When an element loses or gains the charges, so if it gains electrons, it's going to be negative. Loses electrons, it's going to be positive. And these charges, so like for example, if I write this, or if 1 minus or minus 1, if I write that, this charge, you'll actually hear this lots of times referred to as the oxidation number or the charge. Either one, it does come up. So just realize that when I say oxidation number, I'm talking about the charge. All right. Elements want to lose or gain electrons to become more stable, to get more comfortable. All right. So when elements start bonding with other elements and start making compounds and molecules, they form two main types of bonds. They form covalent bonds, and they'll form ionic bonds, and they'll even form metallic bonds. But metallic bonds we don't really talk about too much. The two main types of bonds that we're going to talk about are ionic and covalent. All right, so what's in a covalent bond? Well, here is an example of what a covalent bond is. So if you look at these, you have two hydrogen atoms, each with one valence electron because it's in group 1. Now they bond, and now notice they're sharing those electrons. Same thing here, two chlorines. Here's the Lewis structures. Remember we did Lewis structures? And now they're sharing those two pairs of electrons, and they have a bond. All right, that bond consists of 2 electrons. So the key word here, a covalent bond, is they're going to share electrons. Okay, so they share electrons, not always sharing them equally though, and we'll get more into that later. All right, so when you share electrons in a bond to make a compound, that is a covalent bond. Ionic bonds are kind of, I guess, in the opposite, so to speak. Ionic bonds are going to transfer electrons. All right. So in other words, one's going to give electrons, the other one's going to receive the electrons. So for example, sodium here has 1 valence electron, chlorine has 7. Okay. The best thing for sodium to do to get stable, to get that outer valence electrons of 8, is to give up its electron, form a positive ion, and that electron that it gave up, it's going to give this one to chlorine because it's way more electronegative, so it attracts electrons easier. So now chlorine's a negative charge, and this is a positive charge, so what's holding these together? It's not a bond per se, it's more of the attraction. One's positive, one's negative, opposites attract, likes repel. All right, so now here, let's look at this example. Magnesium has 2 valence, oxygen has 6. All right, so each of these 2 guys need a buddy, so one's going to go here, and the other one's going to go to that. So now they both have buddies. So now you transfer electrons, you're making an ionic bond. All right, and now magnesium is a 2+ charge, oxygen is a 2-. So now they're held together by the attraction, the positive and negative charges of it. All right, generally speaking, not always, but generally, ionic bonds are going to be between a metal and nonmetal. Whereas covalent bonds, where they share electrons more, they're usually going to be between metals, nonmetals. All right, usually, not always, but usually. All right, so if we had to compare and contrast, there's a couple things you need to know. Ionic bonds transfer electrons, right? Whereas covalent bonds share electrons. All right. When you take the difference between these two numbers, the electronegativity I'm talking about, oxygen's way more electronegative than magnesium. When that difference, for whatever numbers they are, when that difference is 2.1 or greater, it's ionic. Covalent bonds can actually form two different types. There can be polar and nonpolar. When that electronegativity is for polar from 0.5 to around 2.1, and it varies a little bit, it's going to be a polar bond. Anything less than 0.5, it's going to be a nonpolar bond. All right? These electronegativity numbers that we're talking about are going to be in your book in chapter 5. All right, so check out the electronegativity numbers. We'll go more with that later. But the electronegativity will tell you what type of bond's being made. All right, and a couple things to keep in mind. Ionic bonds are generally going to be between a metal and a nonmetal, and they transfer electrons. Whereas covalent bonds, they're usually going to share electrons, not share them equally, but they're going to share, and they're usually between metals and nonmetals. Just nonmetals, sorry. All right, so there's the basic stuff about your bonds. There's metallic bonds, but those are also between metals, just metals, so don't really worry about them too much. All right, hope this little tutorial helped. I'll probably put some more stuff up about bonding. Have a good one.